Yeah.
So, hello everybody. We are here to discuss on the question of why do we need fundamental research. We have Dr. Abhilash with us. He will introduce himself. He's doing his postdoc now in Twente.
Yes, I'm doing my postdoc in University of Twente, and after my PhD from IIT Madras in 2016. So today we discuss about why do we need fundamental research. Especially our guest is Tathagata Banerjee, doctor from Indian Institute of Statistical Institute, Bangalore. And he did a PhD in mathematics.
Right.
So the question is, I think in my perspective it is more relevant to you that since you did a mathematics PhD, it's being a mathematician is more of doing fundamental research as far as I know. So what is fundamental in fundamental research in your point of view? And I've seen that there are applied mathematics group as well coming up and people doing research on. Now, what is the difference in general?
So, of course, research by its own, the term itself means we are going back and searching, right? And fundamental research would be like searching on topics which are very fundamental to some subject. There is always a very natural division in the sense that there is the framework laid upon, and then what is the applications of this framework. So that also requires a lot of work, and a lot of people are, the whole industry is working upon that to make that. So, of course, fundamental research that itself is like laying down the subject as I understand it. In my perspective, every research is fundamental in their own sense. You have to ask simple questions and start from there. You have to ask fundamental questions, how you're looking at it. But where you're going towards that research, what is the objective of the research, where is it landing on to, that kind of determines whether the research is fundamental or not. So in my opinion, so if something is the work develops into some application on some structure, then we can say that that is not a very fundamental kind of research. Not a research in a fundamental area in some sense. As you said, applied mathematics and pure mathematics, there's a very big clear line in this aspect.
Is that clear line?
Yeah. So when I was doing my PhD, ours was Institute for Mathematics, and there was and so there was a separate department which is called Applied Mathematics.
But topic-wise, how is it divided?
Right. Yeah. So they study, as I said, what is the objective of the research that you're doing. Whether in applied mathematics, mostly you already have a lot of equation. For example, one thing comes to my mind is fluid dynamics and fluid dynamics. We have been talking about that a lot in the last few days here.
I remember in the department, because I was visiting you and we used to go to your department. There was this guy who was working, I forgot his name, he's quite renowned. He was working on mathematics of knots. The knots basically, you remember that, right? So how different kinds of knots can be formed and...
Yeah, but yes, so...
Yes, so to me that's very fundamental research.
Right.
But why is it under the applied mathematics department?
So he was
is that a valid question?
Yeah, it is. So fundamental in the sense that because the research about knots, the theory about knots have been laid down in the mathematical theory about knots.
Okay.
There is nothing more, if there is something more fundamental to add, that there is this lemma that if this knot goes like that, then this should be the necessary condition, or that should be a sufficient condition for a certain kind of for knot theory, for certain kind of theorem to hold.
Yeah, I see.
That kind of a research would be very fundamental. But if you are applying this knot to some applied areas.
So before that it was abstract geometry.
You have some obstacles or something which is like a knot. and then you're trying to apply the theory of knot theory in mathematics to this problem of solving how to apply it and get a result in application, that would come under applied mathematics kind of area. In my perspective, I mean, I have not worked as such in the applied mathematics department. I've just interacted, and that's what I understand from what they're doing. Interacted with the applied mathematics people.
So one thing that I remember in the conversation is our group in University of Twente, biomedical photonic imaging. So we have different people from different departments. For example, mathematicians coming sometimes for master projects or doing PhD. So basically, what they usually work on is they come as a pure mathematician, and they will be assigned to do some small part of this work that other interdisciplinary people like biologists or physicists or chemists cannot do. For example, if they work on specific like acoustic imaging, let's say photoacoustic imaging, which is based on imaging biological specimens or living or non-living or in vivo imaging methods. What they do is they use acoustic imaging because it has a more imaging penetration depth, because they send in sound, ultrasound focus, and which can travel through the body than the light. So photoacoustic imaging is a big branch, but when they collect image from a technique called tomographic imaging, they don't know how to analyze it, these biologists, once they get this data. So that's where the help from other groups are needed, for example mathematicians or something. So this, if you want to reconstruct complete image in a 3D, so there are many constraints when you image it with some microscope. You will not get the complete volume. So in order to fill in some of the gaps, they have to apply some mathematical concepts.
That's very much applied mathematics. Very applied mathematics.
That's applied mathematics, but these people coming from pure mathematics background comes in, and they apply some regression and other conditions in neural network. But they come like pure mathematicians. But the professors in here explain them what they have to do, and they do it.
Yeah, but I think it's very difficult for a pure mathematician to spend time in learning a new programming language and all these things.
No, they don't have to learn any programming language.
So already they know the structure of that, and
yeah,
so they are quite good. They know how to apply, like since they are quite like pure mathematicians and they have laid down some structure in that area or something.
Yeah.
Is that what I understand? So then they can know what is the knot like and where is the obstacles, where is the restrictions, and so they can know how to go about around it, and so that might make them useful.
Yeah, because they come there just after 1 or 2 meetings.
But that won't say pure mathematicians. But yeah, I think those areas, regression, these things, I mean, this whole statistical area, I think pure mathematics is very much, somewhere you use some very basic subjects like analysis, algebra, geometry and things like that, and work with them.
Would the other one qualify more close to engineering than?
Yeah, I would consider that. Or computer science.
Yeah, mathematics.
Or computer science.
Or statisticians, regression and all these things. Statisticians are like done,
Statisticians
trained for this kind of
mathematicians.
No, I think let's not discuss that who will be in which category.
Yep.
But rather, I think the focus of the discussion should be in
why do we need?
Why do we need? And then the whole point is for a common man. I mean, we are also common man, for common man and woman. So whether we need to use this word that applied mathematics, applied research, fundamental research, and the other question would be that do we really need to do some aimless fundamental research? So that's another big question, that why we. So first question is whether these differences, what we know, should be should be focused upon for the common people, and the second question would be what would be I mean why the society or should allow us to do aimless fundamental research, which has no aim.
Right.
It's just you're just scratching around, and then you may get the gold mine
So
in no time.
that you see, I mean, because of course that is a very good point that you have picked up.
And if I say gold mine, that gold mine may not be the gold mine for the other guy.
No,
right?
so even before you identify gold, I mean, if
exactly.
you hit on gold, I mean, there might be just soil and nothing else.
Exactly.
So that is a very good point that you have picked up, that why do we allow fundamental research, like research to happen in such fundamental areas.
Yeah.
But you see, I mean, all the like big medals in the academic world, like starting from Fields Medal in mathematics to Nobel Prize in the other subjects.
Yeah.
Everywhere they recognize a contribution which is fundamental to the area.
Yeah.
So I mean, I don't know why did they do that.
Exactly. I mean, the
But-
next question would be that.
Yeah, well, I don't know that why did they do that, but so
Why did they do what?
so why did these Nobel Prizes and this Fields Medal came up for that? But you know, the progress of knowledge.
To appreciate the
Progress of knowledge has happened because of people doing this, trying gold in soil and like maybe spending the rest of their life ending with soil. But they have the endless research in fundamental areas.
But
So that is very a good point, that when you are working on a fundamental area of a subject, you are aimless because it might have, you don't have a particular question in your mind where you have to arrive.
Yeah.
You are basically tearing apart what is there, and you are bringing them together back again, tearing apart, bringing them back, and seeing whether something new pops out of it. Right?
And
I mean, that's what you're doing in a fundamental area. If you're working, you don't have a very attainable or target question to go
exactly.
with. So ultimately, nothing might come out. I mean, and that is why, I mean, even in the previous interview, I was saying, like, in mathematics, PhD in our university, in University of Göttingen,
that's not
we are allowed to have a PhD without